I got the red dot. As long as it's red up there, I know it's recorded. So I looked up and it was blue, and I was like, not recorded. All right, so here we're doing integrating with long division and completing the square. And again, the reason why we're doing this is to try to help us simplify the problem a little bit more so that we can do the integration easily, maybe get it to a point to where then we can truly use U substitution. Because, like right now, it wouldn't help us to split it up as 3x cubed over x minus 2 and then minus x squared over x minus 2. It's not going to help us like it did on the earlier time when we were dividing by a monomial, and we could go ahead and split it up and reduce our stuff. Here we're going to use long division on both of these is what I'm going to go through and do. Now there's quite a bit of room, but again, you just got to be careful on what font you are writing in, so like size-wise. So long division, we take what we are dividing by. I think I can squeeze it out here, as long as I get the pen turned on. There we go. I have x minus 2 divided into 3x cubed minus x squared minus 5x plus 1. Again, the whole goal of long division is to figure out what do you need to multiply the very first term by, the x, right, in this case of the binomial. What do I need to multiply by to match the very first term on that row? Yes? 3x squared, very good. So I multiply by 3x squared. That gives me 3x cubed. And then I multiply 3x squared times negative 2, which is a negative 6x squared. And then long division, we subtract down. So that means that I usually multiply through by a negative 1, so it becomes a negative 3x cubed plus 6x squared. And then now I add down, and the 3x cubes cancel. And then negative 1 plus 6 is a positive 5x squared. Bring down the minus 5x. And then I go through the process again. What do I multiply x by to make it a positive 5x squared? I got to multiply by a positive 5x. So when I multiply by a positive 5x, I get 5x squared minus 10x. Sorry, you can't see my 1 on the 10. Now, we subtract down. So that's multiplying the bottom by that next row by a negative 1. So the x squareds cancel. Negative 5 plus 10 is a positive 5x. Bring the 1 down. I keep doing this until the degree in what's left over at the bottom is smaller than the degree of what I'm dividing by. So right now I have equal degrees. It's x to the first and x to the first. So I keep doing long division until I get to where, hey, the degrees on what's on left inside that division part is smaller than the degree of what I'm dividing by. So with this in mind, I got to multiply by a positive 5. That gives me 5x minus 10. And again, multiply negative 1 there, and that becomes an 11. So I have a remainder of 11. So we write our remainder, since it's positive, as a plus 11 over what we are dividing by. So it's 11 over x minus 2 as a quantity. And now I'm ready to put that after the integrand sign. Now I'm ready to come over here and say I got to find the integral of 3x squared plus 5x plus 5 plus 11 over x minus 2 dx. So I just took something that U substitution would not have helped me to do in the beginning. Doing the long division allows me to manipulate it to where I have a nice workable, really loosely using this term, polynomial, because again, 11 over x minus 2 is not a polynomial technically. But getting a nice thing that I can easily start doing integration by parts and stuff and figure it out. So now we say, all right, that's x cubed plus 5 halves x squared plus 5x plus 11 ln of absolute value of x minus 2. Again, I don't have to worry about doing an extra piece on that part because there was an x in there. So the derivative of x minus 2 is just 1. So, and then plus c. So again, we are using the long division to help us manipulate the original problem mathematically, properly, to where I can get it to be a workable, easier antiderivative to take the antiderivative of. Now the next one, we're going to be careful because if we notice what the denominator is, it's 3x minus 5. So we're going to need to do some u substitution when we get ready to take that antiderivative. Okay? But let's go ahead and do our long division. So 3x minus 5. If we by chance happen to be missing one of the terms in the sequence, what am I supposed to put in? Yeah, 0. So a plus 0. So if you, again, it's been a while since we've done long division. Okay. Did you do long division in pre-cal? Okay. So I taught it to you. Miss Bernard and I, we taught it to you in algebra 2. Also, quickly, if she did it, it was the very beginning of pre-cal. So and then you don't use it much, and so it's been a while since it's been a minute. Maybe an hour since you guys did the long division. So if you're missing a term, you put a 0 in the spot. So I multiply, what do I multiply 3x by to get 6x to the 4th? 2x cubed. That gives me 6x to the 4 minus 10x cubed. And then I multiply that line by a -1 to switch the signs. And the 6x to the 4's cancel. That gives me a positive 3x cubed. Bring down the plus x squared. And then now, what do I multiply 3x by to make it a 3x cubed? That'd be just an x squared, so a plus x squared. Gives me 3x cubed minus 5x squared. Multiply through by a -1 to swap the signs. As we subtract down, 3x cubes cancel. That gives me 6x squared. Bring down the plus 2x. What do I multiply 3x by to make it a 6x squared? Plus 2x. Gives me 6x squared minus 10x. Multiply through by a -1 to swap the signs. 6x squareds cancel. I get 12x. My degrees are still equal. There's no other term, so it's like when we put the decimal point in a 0. We just have plus 0 is what we kind of bring down. Okay? Is all we're doing. So now, what do I multiply a 3x by to make it a 12x? Positive 4. So 12x minus 20. Swap the signs to make them negative positive there. And I get 20 as my remainder. So it's plus 20 over 3x minus 5. Now I have my workable function to take the antiderivative of. So now we have the integral of 2x cubed plus x squared plus 2x plus 4 plus 20 over x minus 5, all in parentheses to the dx.
Should be a 3x.
Where? Oh, yeah, there's a 3x minus 5. I even said 3x minus 5, right? Did I?
I think you said
Did I just say x minus 5? Make sure as on the AP test, because again, math teachers were picky. If you just wrote that down and didn't put parentheses around it and you just put the dx on the last term, some of them are going to not give you credit for having the right format. You got to have that whole part in parentheses. Okay? It seems like it's nitpicking, but again, based on how they have to grade by the rubrics, it'll say, do they have the right format? It means every little bit correct. Okay? I'm going to quickly over here to the side say that if my u is equal to 3x minus 5, so du is equal to 3 dx, and dx is equal to du over 3. And so, as we do this, I'm going to rewrite it one more time. Again, we can do this as integration by parts, so we're allowed to split this up as 2x cubed dx plus the integral of x squared dx plus the integral of 2x dx plus the integral of 4 dx plus the integral. Now, this is where I'm going to do my u substitution. 20 over u times du over 3. So that's where I'm substituting in the du over 3. As I split this up into parts, integration by parts by using our property that we learned, when I don't have to do 1/3 times everybody. Everybody doesn't get times by 1/3. It's really only that last portion question.
Say we have in our equation that 20 over 3x minus 5. Can we just do it? Okay, do it.
Sure, Vermont. It is. Laplace. You learned it today. He's in Cal 3 Laplace. Okay. You gotta do your Laplace. Now there's some fancy stuff. It's like they're eventually like in Cal 3 you do integral. I mean, you get some fancy stuff we get to go through. I mean, it's, you know, the nerds that like math is like, oh yeah, this is cool. But yes, no, Jeffrey, you're good. You're good. I mean, you know, I got to make sure I cover, you know, where that is. But that's what I would have gone through. I would have said, okay, I got to make sure I put a 1/3 out front. Okay. So now as we do this, we have it's to the 4, so it's 1/2 x to the 4 plus x cubed over 3 plus x squared plus 4x plus, it's a fraction technically because it's over 3 there, so it's 20 over 3, whoopsies, I wrote my 3 to the wrong place, 3, and then it's ln of whatever u is plus c, and then we can just substitute back in what the u is. So 1/2 x to the 4 plus x cubed over 3 plus x squared plus 4x plus 20 ln of 3x minus 5, all of that over 3, and then plus c. Okay. But again, you don't have to do that second step showing if you don't want to, but we do need to make sure we take into account, since we're dividing by, there's a coefficient on that x, we need to make sure we're using the u substitution to make sure we remember to put the 1/3 back in to account for it. So when we take the derivative, we get to what we have. Okay. Any questions on long division? It's long. Okay. All right. Using completing the square. Now, why are we trying to do using completing the square? We're trying to use the completing the square to do inverse trig, antiderivatives. That's kind of the purpose of why we're doing it, is when I realize, like, I got 1 over this thing. So when I see 1 over a polynomial there, and it's a quadratic, I got to think about, well, hey, that's like arctangent, 1 over x squared plus 1. So if I can do completing the square to create a 1 over something squared plus 1 or whatever, then I can use arctangent to rewrite it for an antiderivative, okay? Or like here, I see a 1 over the square root. Well, I'm thinking maybe the inverse sine is what I'm thinking of, okay? Or maybe inverse cosine or whatever. I'm not using, in a way right now, I'm not using inverse secant because there's no absolute value of x outside. You know, maybe if it was like x to the 4th plus x cubed and then 15x squared, and you separated the x squared and took the square root of it, brought it out front, then it would be an absolute value of x. Okay, so you know, that's where I could see maybe using the arcsecant and so forth on there. So that's the purpose for the completing the square. Hey, we're trying to use inverse trig for the antiderivative. Okay, so with that in mind, how many of you remember completing the square? How many of you have forgotten completing the square? And it's okay to be honest. Okay, again, last time you used it was the beginning of pre-cal, whenever you took pre-cal, the first maybe 2 to 3 weeks of pre-cal. All right, haven't used it since. So those of you that had pre-cal last fall, it's been a while. Those of you that had pre-cal 2 years ago, really like a long time ago, okay? So some of you had in the spring, not as far off removed, but still, we don't use that skill a lot, so that's why it's easy to forget. So with that in mind, I'm going to take over on the left-hand side to make it a little bit easier to look at. I'm going to take the quadratic on the bottom. And when we do this, basically what we do, we got to make sure there's no coefficients on the x squared. So we would want to factor it out accordingly, but they don't get that nasty for us. Okay? So I'm going to rewrite x squared plus 6x, give it some space, and then put a plus 10 is what I'm going to do. And just scooch the 10 over to the side. Now, in the process of completing the square, we identified the b term, divide it by 2, and then I square it. So my b in this case happens to be 6. 6 divided by 2 is 3, and then I square it, which gives me 9. So I add 9, and I also subtract 9 because I got to balance what I'm doing. I add 9 and I subtract 9. Now, let's take what we have right now and rewrite what we have as our integral with that as our new denominator. Okay? So we're going to go over here and say this is the integral of 1 over x squared plus 6x plus 9 minus 9 plus 10 dx. Now, we're going to simplify the negative 9 and the 10. This is the integral of 1 over x squared plus 6x plus 9 plus 1 dx. Now, we created a perfect square trinomial with the x squared plus 6x plus 9. That factors in. That x squared, the x squared plus 6x plus 9 is technically x plus 3 quantity squared. Yo!
So are we just trying to make a perfect square in the bottom and just leaving a number to the side to make a perfect square?
Well, we're trying to make a perfect square in the bottom, yes, but we also need to make sure it's a plus 1 after, okay? If it's not, we're going to show you how to do that. Because they're not always going to be this pretty to where, hey, when I do the completing the square, the negative 9 and the 10 make a 1. Sometimes they're going to combine and make a bigger number, so we got to learn what we do there, okay? But again, they never try to slap us upside the head on the first problem of trying it. They always take it, ease it in. So now I can rewrite this as the integral of 1 over x plus 3 quantity squared plus 1 dx. Again, if you want to use substitution, you can. You can say u is equal to x plus 3. So du is equal to dx. So then I can substitute this in as the integral of 1 over u squared plus 1 du. Now, this should spot in my mind, this is arctangent. So this is tangent to the negative 1 of u plus c. And then I would go back and substitute in what u is. Woo. Okay. Now, do you have to do the u substitution since... No, you don't have to. You can if you can say, hey, the x plus 3 really is not going to give me extra coefficient out front I need to worry about canceling out. You can just leave it in that way. Okay, just whatever works, right for you. All right, number 4, we kick it up a notch. Okay, we kick it up a notch. So I'm going to take number 4 off to the side here. Okay, let's make sure I follow my notes carefully just because of that negative. The negative in front of the x squared, we're not allowed to have. So we got to be careful with what we're doing. So I'm making sure I'm careful with my notes. So again, I'm thinking, my anticipation, we're going to use arc sine for this one. That's my anticipation. Okay, we know arc sine for the derivative of arc sine would be 1 over square root of 1 minus x squared. So that's what I need to work to as a final version. Okay. And that's why there's that negative out front. It's going to help us with that process. So if I have negative x squared plus 8x minus 15, bring out the negative 1. That gives me x squared minus 8x plus 15. Now let's go ahead and start the completing the square process. So it's negative 1 times x squared minus 8x. Give some space, a plus 15. And then now, give me a second. Make sure I double check. Yeah, I haven't made a mistake yet. All right, now, half of 8 is 4. 4 squared is 16. So we would have a plus 16 and a minus 16 is what we would have. Now, the x squared minus 8x plus 16 is a perfect square trinomial. We can now combine the negative 16 and 15 if we want. Okay? Eventually, it's got to go outside the parenthesis. So we can combine them, and let's go to that next stage of negative 1 times x squared minus 8x plus 16. Negative 16 and 15, positive 15 make negative 1. Now I'm going to take the negative 1 out back. When I do that, I got to multiply it by that negative 1 out front. So this is negative 1 times, I'm going to rewrite that as I'll do that. We got plenty of room. And then now it's a plus 1 at the end. When I bring something out of that parenthesis, since there's a negative 1 out front, I got to multiply by whatever it was. If I brought out a negative 2, or a 2, I would have to multiply the whatever's coming out by the 2. Okay? So now this is negative, and then it's x minus 4 quantity squared plus 1. That's now my new bottom. So I have the integral of 1 over square root negative x minus 4 quantity squared plus 1. Again, if I want to use u substitution to make it look a little bit nicer on my eyeballs, I can. We can swap places now. And I can actually rewrite the inside as the square root of 1 minus that quantity squared. So now we're getting closer to the format of 1 minus something squared. And then again, this is where if you want to do u substitution, u equals x minus 4, du equals dx. So there's a dx there, there's a dx there. So it's the integral of 1 over square root of 1 minus u squared du. And then now we would say that is arc sine of whatever u is plus c. And so arc sine of x minus 4 plus c. Again, doing u substitution on this part, not truly necessary since the derivative of u is just 1. So it's 1 dx. So you don't really have to do it if you don't want to. Comes in handy if we had like the long division when it was a 3x minus 4. If we had something in there that was a little bit different. So again, but they're typically not going to do that to us. Okay, they're not going to really have it be that crazy. All right, number 5, one more to go. All right, and again, if you want to work ahead of me on this one, this is another one. I'm thinking, hey, there's no square root involved in the bottom. So what inverse trig should I be thinking about? I should be thinking about arctangent. So again, as an idea, so again, no square root. So we're thinking about arctangent. Okay, that's what we're thinking about format. I'm thinking about getting this into 1 over x squared plus 1. That's what I'm trying to figure out how to get it to something like that. Okay, so x squared minus 4x, and then I'm going to leave a space plus 20. Half of 4 is 2. 2 squared is 4, so I get to add 4 and subtract 4. So that becomes an x minus 2 quantity squared plus 16. So I'm going to go ahead and rewrite the bottom. The integral of 32 over x minus 2 squared plus 16. Okay. Now, here's the challenge. In order for us to do the inverse trig, we know we can pull the 32 out front. We know we're allowed to do that. And that would give us a 1 on top. Okay. The problem is I don't have something squared plus 16 on the bottom. Okay, the 32 can come out, that's a 1, but I don't have a 1 here. So this is what I need to go through and do. And I need to do this carefully, and I will use u substitution. Okay? Because this one, as we do it, there's probably more than one way to do it, but I'm going to hopefully show you the least confusing of it. We are going to go through, and I need that 16 to be a 1. All right, well, in order for it to be a 1, I got to divide it by 16. Well, if I need to divide it by 16, then everything in that problem has got to be divided by 16. So I need to divide the fraction, or the x minus 2 squared by 16, and I got to divide the 32 by 16. Everybody gets divided. All right, not just that one part, and not just the bottom, the whole problem, because it goes back to that properties of equalities. Okay, I got to divide equally across the whole problem. So what does that give me? That gives me the integral of 2 over. I'm gonna do this in stages. X minus 2 squared over 16. And then plus 1 dx. So I'm getting closer. Now, let's rewrite the x squared minus 2 squared over, or sorry, the x minus 2 quantity squared over 16. Can't we do this? Can't we say that x minus 2 quantity squared over 16 is equal to x minus 2 quantity squared over 4 squared? Can't we say that? Now, since we have the same power squared and squared, I can rewrite that as x minus, sorry, bigger parentheses. Bigger parentheses. I can rewrite that as x minus 2 over 4 quantity squared using the exponent properties. We learned back in 8th grade, we can take the exponent on the outside of a fraction and distribute it to the numerator and denominator as powers. We're just reversing that. I rewrite the 16 to match my powers, then I can encompass it all underneath one thing. Now I have my nice u being squared. So I'm going to let u be the x minus 2 over 4 is what u is going to be. Okay? And this one we will need to use the du. So we're going to say u is equal to x minus 2 over 4. And when I take the derivative, du is equal to 1, just 1/4 dx is what it is. Now, if you want to split up as x over 4 minus 2 over 4 and then take the derivative, you can. But here I'm just thinking, hey, that's really just going to be 1/4. So dx is equal to 4 du. Now we're ready to substitute in. So let me take this back up here. So it's the integral of 2 over, and we said this was x minus 2 over 4 squared plus 1, and then dx, and then I start my substitution, 2 over u squared plus 1, and then it was times 4 du. So I'm going to do 2 times 4 is 8 and pull it out front. 8 times the integral of 1 over u squared plus 1 du. Now 8 times arctangent of u plus c. So it would be 8 times arctangent of, now my big crazy fraction, x minus 2 over 4 plus c. Isn't calculus fun? Now, as we look at the rest of the problems and the homework problems, they don't get that tough. That's just the worst case scenario. Okay, that's the worst case it gets. Okay.
That won't be on our mastery check.
I can look at the mastery check. I have it over here.
That's just really easy to get lost.
It is. It is so easy. It really is. And so, man, that's why you guys chose the class. You're like, I want to be lost.
You retaught us completing the square.
Do what?
Beginning of the year.
Did I forget that we did that?
You retaught us.
Did I?
And then we still forgot.
And we still forgot.
I mean, thanks for
Holy
giving us
crud!
Thanks for giving us grace on it, but we all forgot.
We
Yeah,
collectively
we
got
did
like a
like the
30 on
review.
that.
Like, the
I don't want to
first
talk
test,
about
that
that.
was like
I don't wanna talk about that.
I'll say at the end of the year, our final should be that beginning review.
No,